Hello, everybody. Aaron. Welcome to the healthcare panel. My name is Alexey Krabarov. I wear many hats. I'm a chief scientist at Nitro, which is a document productivity company. I also run developer communities and data scientist communities in San Francisco Bay Area. I'm the founder of Scala and Spark meetup, and also its conferences, Scala by the Bay and Data by the Bay. Scala is a vehicle for a lot of data analytics using Spark and H2O, as you've seen. We actually run Scala by the Bay 4th year at Twitter in November, and we'll have a specific track for data mining and machine learning. So if you want to delve into Scala, I welcome you to join our communities. So it's an honor to be here. H2O is a longtime partner. They really do pioneering work, and I was really inspired by Shree's keynote, where he mentioned specifically kind of open source ecosystem for data. We see a lot of new data emerging in sequencing, in patient healthcare, and obviously we're in need of merging all this. So we have really great folks with us on the panel today. I know we stand between you and lunch, so we'll be very focused, and we'll try to cover all these topics, but efficiently. So I'll let all the panelists now introduce themselves, and maybe you guys, when you do that, maybe you can take a minute or two to highlight, your key interests and kind of key challenges you see for yourselves in your companies, and also maybe if you can tie it into this whole open source ecosystem for data in healthcare, if you can kind of provide a few insights, and all that in that 1 or 2 minutes. We'll start with Jordan.
Okay, all right, you can hear me. So I work at Optum as a principal data scientist, and Optum is kind of a sister company of United Healthcare, and there are about 100,000 people in Optum and another 100,000 in United Healthcare. So pretty big company. And the group that I'm in is called Advanced Analytics Lab. So we're focused on payment integrity, which is basically finding claims that are overpaid mainly, but we have other problems that we actually deal with. So challenges, or that's, okay, challenges. It's one of these places where legacy software is used, like SaaS, and when I started 4 years ago, I was probably mostly R user and then SaaS user. Now I'm at this point kind of the other way around, and since the fall, probably, when I learned about H2O, I was trying to use it, and the good news is that we have a platform that we just set up at our group that can use the vast data that we have in the company, but give us the chance to install software that we can test, like H2O, R, and other tools of that sort. So the challenge is how to really make this transition. And yesterday people talked about that, but I think maybe just doing one project at a time is the way. So we have a sandbox there to play. Hopefully it will work out soon for us.
Okay, thank you.
Jordan Slavov. I'll give it. Thanks.
All right. Thanks. I'm Manuel Salgado. I'm Senior Manager for Advanced Analytics at McKesson Specialty Health. And I guess you guys know, just to give context, so McKesson is one of the largest, or the largest drug distribution company in the country. It's a Fortune 5 right now. But Specialty is a unit within McKesson. We're about 20% of that, and we are focused essentially on the oncology space and all the multi-specialty space. Within there, I'm part of the team, the enterprise data management team, where we essentially, aggregate all data from our different providers, whether it's EMRs, whether it's claims data, whether it's all types of data we have access to, and then we essentially turn that data into insights for our clinicians and our folks that are practicing. What I would say we have many challenges. The question of challenge, but I'm going to highlight what I think the top two. One of them is technical. So healthcare data vis-a-vis other types of data is very there's some standards, but there's not the degree of standardization that you have with other fields. And before healthcare, I did financial, so there everything's very, very standardized. But in healthcare, you have, of course, a push to do EMRs, to essentially put all the records electronically. Even before that push, we didn't even have that. So now we have that. But then you have EMRs calling similar things by different names and making the process of integrating that data from two different EMRs challenging. Plus, you have the physicians as well who have their habits, and they most of them like to not deal with the EMR. They like to speak and have one application transcribe that directly into the workflow, and that presents some challenges, of course, understanding the not only English but then oncology-based English. So technically, I think the data format disparities are one of the biggest challenges that we see. From a business perspective, I think when you talk about advanced analytics, it's a topic that even today it's sort of mystic, if you want to call it. Some people don't really understand, and it's hard to make that connection, right? To show someone, without having to, if you get too deep into the technology, you lose a lot of people, right? So how do you break it down, but in a way that you still, help folks understand how this can really help you and really. I don't see it so much as a job replacement, but as a really good aid that can really guide you. You're like in the cockpit, and this thing is giving you a signal there that you didn't have before, and that drives your decisions way better than without it. So, how do you, making that case and making sure that there's a proper investment, there's a proper commitment to fund those initiatives. I think that's the other.
Thank you.
Tim Gilcrest, I work for Resolution Health, and what we do is look in clinical data for health gaps that people have. So you're taking too much medication, not taking enough, you haven't seen your doctor, and we'll use behavioral economics principles to intervene with those people. We'll have a nurse call them, we'll send them a package of information, get on their mobile phone, things like that. I'm also a fellow at Columbia University's Health Innovation Lab, and we teach at Columbia. We support companies that are startups in health technology all over the world, and we run pitch fests all over the world to expose those companies and get them funded as well. And for me, the challenges are very similar. At RHI, we're interfacing with a galaxy of electronic health records. The US government has put $60 billion into funding these health records, but not any effort into standardizing their output. So it leaves us running around trying to put it all together, and now we're interfacing with wearables as well, which is very similar. No standard, which keeps us very busy. And I guess to add on to we should do this together. Yeah. To add on to your point, I'd say that the science of pattern recognition and artificial intelligence, I hate using that word, machine learning, is rocketing along. But the way we manage companies is not, and the two are doing that. There aren't a lot of data-driven management styles out there that can absorb machine learning very easily.
Interesting. Thank you.
Hi, I'm Marc Landry. I'm a data scientist at H2O, but I did spend 7 years at a healthcare plan, and we were purchasers of both of these guys' products. Mine is actually the same as theirs. I mean, I remember attending the Optum conference a couple years in a row and knowing that they were getting ahead of, HL7. We're going to get all these lab values standardized and everything, and then you realize nobody does it. The EMRs are all different, and HL7 is a standard. That's the right direction, so we can get behind that. But it's still sporadic the way you see it. It's difficult knowing what people, getting people to work with it. It's sparse data. You see that on the NLP side. We've worked with Manuel on some of that, and it's a challenge to do. I mean, big data has been a thing for a while. Healthcare fits that in a lot of different ways. It has nasty data. It does have a standard. It's interesting leaving and working at Dell for a little bit, and you realize when there's no standard, there's no structure at all. But healthcare has a standard, but it's still not readily applied, and so it's difficult to work with sometimes. To pick a different flavor, since it's kind of the same as they're saying, I think it's interesting from a modeling perspective how we blend the different types of data we have together. So I've kind of alluded to two. So we have this nice diagnostic procedural data that we get that we're all sharing together roughly. You can look it up from CMS, that kind of thing. And then you try to merge that in with a model that takes like genomic data or something like that, or even these sparse NLP type things of the lab values that you're reading, that's difficult. And there are papers written on the difficulty of making these challenges work because mainly our algorithms start to pay attention to that dense diagnostic data and they start to ignore the genomic data. It's very tricky to actually get those to really merge correctly. So I think it's an interesting thing to follow because your normal machine learning practitioner is just going to fire it in the tool blender and see what happens. And it's difficult to get insights that most of that was ignored. So it'll be interesting to see how we face that as we do get to blend more of these big data sources together.
Hi, my name is Francesc Loveth. You've seen my talk. So I'm more in the research side, but I see different challenges here, right? So the examples that I give you, so those examples are clinical applications, but those people had to know the researchers to get access to that clinical application. So it wasn't just a family that went to the hospital and needed help. So I guess when the cost goes down, this is going to be more accessible to everybody. So that's one of my hopes, that it gets accessible to everybody, right? The other thing is going to be being able to communicate the findings to the doctor and the doctor communicate the findings to the patient in a good way. Because not all the findings that we have are actionable. So we have the case, breast cancer probably is one of the famous ones with Angelina Jolie, right? He had a mutation in a gene called BRCA1, and he took a decision of removing her breast. But those are just a fraction of the findings. Another thing that recently got my attention was that how complicated it is to share data. Mm-hmm. So we produced, for the Center for Mendelian Genomics, in 4 years, we sequenced 10,000 individuals. Out of those, we can only share 1,500. So it is complicated, and I'm hoping that we're going to find ways to be able to share the data.
Thank you. So I think we kind of outlined the whole set of topics, and I think it's amazing how broad, what we call healthcare or life sciences is, right? So we go from genomics to patient payments and fraud on actual and medical insurance. But in the end, it's all, like, I think we're all kind of trying to model the patient, right? Because if you want to validate payments, you need to understand the condition, right? If you want to do personalized medicine, you effectively want to kind of figure out the predisposition. So I think one topic I see emerging is this variety, incredible variety of data sources, right? So if you're Amazon, actually, your data is much more homogeneous, right? You have a catalog, right? You have customer sessions and so forth. So I think what strikes me is with this real huge diversity, and several folks mentioned that you need to kind of join this data. So maybe we can talk about what kind of joins between this data is possible. One thing I know from kind of my advisor practice, I advise a few startups in genomic space, and they can actually get sampled genomes, right? There is 100 genomes data set, but they cannot get a single electronic patient record because of the regulation, right? And so we can get millions of Medline publications, right? We have sea of text, so we can try to use NLP techniques to match it, but we cannot, again, easily get a few lines the doctor wrote. On the other hand, we know that the patient data belongs to the patient, right? However, we're not there yet with kind of an easy way to join it. So maybe you can talk about what data you find most promising in your own use, what data is not available, and kind of where do you find this kind of advantages, like which kind of data basically do you need to do your jobs better, and how this open source ecosystem can help organize this data. What about data standards? Are we there yet with this data standards for interchanging this data? If you can talk about that. In any order. By the way, if you guys feel like having a discussion among yourselves, it's totally fine. I think we'll allocate about 10 minutes in the end for audience questions. So, it's informal. Yeah.
I can start with exactly this point that we have a lot of data, but it's not available most of the time. And excluding the pure fraud in my work, we really don't look into the patient's data. We just look at the provider's behavior or their submission of claims. So things like the code that they use to charge for the service and what diagnosis code that they put there. And The reason is simple. If we were not very, very close to 100% perfect, then we'll create a lot of abrasion, it's called. So basically, we will stop claims or ask the providers to give us records, etc. And if 10% of the time we're wrong, it's going to be kind of a problem. Maybe we'll lose that provider. So that's one thing to consider. And the other thing is it's standardized data, but it's interesting that maybe excluding the payment when people actually, if they're they're fair, they really are correct because they want to get the amount of payment for the work that they did. The other important thing that is the condition they treated the patient for. So this ICD-10 codes now, they are so noisy that often they're actually probably make the things worse than helping. So this is kind of type of problems that I have. So on the payer side.
Okay.
Yeah, I think that that's right, and to add on to that, so the data sharing is a challenge. I would say healthcare data, from what I've seen, is one of the most protected data sets that are out there, and that's why it's so hard to, me working at McKesson, that gives me the advantage that we have a large network, in particular for oncology practices. So we have, we can work with, based on the data sharing agreements between the practices and McKesson, we can work with that data in certain ways. But, if I weren't there, I would be faced with that challenge because there's not a framework for. There's a concept of de-identification and there's a concept of masking and all that, but there's not a standard framework for applying that and then sharing the data. I think that there's some technologies that address as part of it, but there's not a single solution that somebody can buy, drop, and boom, you got the identified data, you can share it, do whatever. So, I think that's one of the things that we're actually looking at right now are being able to grow those capabilities. But that's one of the challenges that we're seeing, that there's not a single offering that makes it easy to do that.
So do we need regulatory help? Is this something we can solve technically, right? Because anonymization is basically a whole area. So is this something where kind of industry, government, and technical community can partner? What do you think is the avenue of action here? Like, if we want to have a standard medical record data set for Kaggle competitions, how can we get there?
Yeah, that's a tough topic to start. I would say it's tough. I don't know if I have an answer for that because working at that same healthcare plan, I stumbled onto a $3 million Kaggle prize, which was laughable because to get that through, they had to anonymize so much that I worked for a tiny little healthcare plan. We had so much more data to actually solve that same problem. So yeah, that's an issue to share the data. I mean, privacy is important. So there are methods that people ran that competition's data through an actual methodology that's getting developed to show how secure it was. So people are working on ways to ensure that it's anonymized enough. That doesn't get you away from rare conditions are going to be rare conditions and you can't share things. Like the state of Texas, I think, used once you get above 5, you can start to show some more details, but it gets edgy. And the state of Texas they were offering us data sets as well. Once they've aged for a little bit and you've anonymized it correctly, that at least helps. Because what we're really talking about is exactly what Manuel just said, is that the Optums and the McKessons of the world and the Uniteds are sitting on top of a lot of this data, and the rest of us are not. So and there's value to that. We need more observations to see it. So I think that we'll get better at that, figuring out what we can still get away with showing, and developing procedures to let everyone feel more comfortable about sharing. But I don't know how far that road takes us, because still a lot of the stuff we really need to get our hands on are rare events, and the anonymization that we're headed down is going to protect those rare events from happening, because it kind of is a giveaway for privacy.
Maybe I'll kind of focus in on this a little bit. So Jordan mentioned medical coding standard, right? And I think there is UMLS, which is a medical language. So when we talk about medical conditions, right, it's a very diverse hierarchical set. So how good is actually the state of this current medical standards? And so, as data scientists, we basically I think we love our schemas, right? If you talk about data engineers, they have Google protocol buffers or ever schema, so which are extremely well defined. I mean, at the bottom of this are TCP packets, right? If a TCP packet is poorly defined, it will not arrive. So the whole internet is basically driven by very well-defined data. My impression from what Jörn mentioned that medical coding is not there exactly, but the question is how well defined are the conditions, and for instance, like I know we can match a lot of text to other text. So a lot of people basically, when they're computer scientists, they just basically match blobs of text to some keywords. They kind of infer, they reinvent the meaning through topic analysis, through summarization. So how useful is it to basically map free text onto UMLS or this ICD-10? How well defined is this? I mean, are we better off kind of using common sense and looking at bodies of text? Should we resolve this to UMLS nodes and use UMLS as our data interchange?
Well, it's an interesting question. I think that there was a lot of effort, expert effort to create these hierarchies for the different codes, conditions, and so that that maybe is an optimal solution at the moment, but I'm sure they didn't use any text analytics, and they probably should have. So that's more relevant, I think, it's to other situation when the treatment starts and you want to somehow make a prediction what's going to happen and things of that sort. Then there are nodes that the doctors have, or if there are payments, there are nodes there too. So that's some source that actually can help. But in terms of I have actually another favorite topic, so I'm just going to mention it. A lot of the wrong payments happen because providers have contracts that are wildly kind of modified from standard templates, and I think it's not a secret, but we probably have hundreds of thousands of contracts in our database in United Healthcare. So it's really hard to track certain changes in the contract. I mean, what they cause. So I really think it's kind of an interesting AI problem, just to see how legal document actually, with these rates embedded, creates overpayments or possibilities to abuse the payment system. So at that end, I think there is much to be done. Well, diagnostics, I think
for the non-healthcare people, a little bit of explanation. So your doctor gets an electronic health record, and you show up in the office, and many times, instead of going through all the proper forms, they just start typing in the notes, which would be the natural thing to do. It leaves us with the problem of having to run NLP on the notes rather than go through the structured data from the electronic health record. As you can imagine, that's a problem. But for me, I wouldn't look to the establishment, if you will, as the solution. You've got, a fragmented system of collecting data. And also you've got Google and Microsoft playing with health data and then backing away from it, which happened a few years ago. And there's also this, the truth that when we go to the doctor, we often lie, right? We're saying, oh, sure, I don't drink, and I eat nothing but kale, right? So the doctor is only seeing part of your experience. So for me, the promise would be a more universal system that's collecting data in cooperation with clinical data, but also collecting things like how much do you move every day? Do you floss your teeth? Which has a surprising correlation to heart health. Things like that. How do you get something that's as ubiquitous as a smartphone, collecting that data and giving it back?
And I would say that, one of the points there was coding. I think coding medical information, it's needed. So you can't get away from that. Because at the end of the day, if you're going to feed this to a machine learning model, it has to be it gets turned into ones and zeros at some point, right? So you have to be able to code similar things with the like. Now, there you also have a problem because if you're not aware in healthcare, there's not, it didn't start with one uniform code system. So you had ICD codes for diagnosis, and you have long codes for labs, and you had particular HCPCS codes for procedures. Now I think that through this initiative, you're getting to what is called the SNOMED. That's the Uber code. They're trying to build a system that encompasses all of them, but it's still a work in progress. So it's something that definitely should be encouraged, so that we can, if we can get to that state, and then you still might have to do some NLP, you still might have to infer from the text of the doctor what code might be for what they're trying to talk about, but you at least have something you can go with and start doing some fuzzy logic on it.
Mm-hmm. Yeah, makes sense. But then, of course, you need to validate it, because often doctors will mistype the code, right? So you still need. So I want to pick up on this, Google, Microsoft kind of wading into healthcare and kind of wisely stepping back, right? I think it just shows the challenge. I remember Google giving talks about how they're going to basically handle prescriptions, send to pharmacists, and then folks would raise issues of privacy and would clearly see that they did not consider all the ramifications, and so we don't see actually a lot of offerings. So I kind of want to follow up on Sri's original keynote, where he mentioned this open source ecosystem for treating cancer. And I think actually it kind of aligns very well with what I see in Bay Area communities and startups. They're actually turning into the same data tools which H2O uses, Scala, Spark, H2O itself, the set of data science surrounding it, and multiple groups are trying to kind of move this personalized medicine ahead, right? And so my dream is that we'll have a Kaggle competition to solve cancer, right? With $1 billion prize, and the test case is cancer is cured, right? And so kind of the input is actual, medical records of a patient with cancer, right? So question is, obviously, we need to gather as a community. So I want to to share how do you go about learning all of this, right? We're here at the community gathering, and I think we're all different stages. Jordan said it's one project at a time. It's a learning experience, right? So obviously we need to engage open source practitioners and partners like H2O and other companies. So how do you see this collaboration between your companies, open source communities, providers of tools like H2O going? What's a good way for you to hire people? What's a good way for you to learn about these techniques, and what can you give back, right? So, for instance, a lot of folks in my meetups, they can donate their time. So there is a lot of senior engineers in Google, Amazon, Microsoft who, instead of building another pet store on Ruby on Rails, they'd rather solve cancer. So they have time. They have, some free hours. They know distributed systems. They know machine learning. How can you give them tasks? Can you kind of separate some problems? How can you engage with the community?
That's tough. I'm trying to think through it, and I think all of us are going to say it's a tough one because of the many issues with data sharing. If I had to take a crack at it, I think that we may have to look at how to maybe not share data, but share models off of the data, right? So once you're, that would allow you to keep the data set where it's at. You don't have to expose it to anyone, but you can share models. And if you can, different people with different data sets arrive at different models, then you can look at them and somehow merge them and arrive at a better model that way. It's kind of like adding a layer, I don't know what you guys think, but kind of like adding that layer of abstraction, yeah.
Yeah, what they do in statistics, like meta-analysis from different studies.
Yeah, and that's the intrigue of deep learning. So I know that one of the avenues we're exploring with that is cancer imaging, and so look at that, and that's exciting about the GPU kind of solutions you'll hear us exploring now, is that these models can be shipped. I mean, you could ship a GBM, but you better, it doesn't really transcribe from one to the other. The interesting thing about images is that it's actually a pretty easy task to get this image to look like an image. You give a template of a few, just get it in these pixels. So you do see ImageNet. There are these standard data sets that are out there, standard models, architectures that are out there, pre-trained networks. And so I think that's an exciting thing, and that does offer you, it would seem, maybe it's a not thought through opinion, but it does offer you that privacy. So we have the data, we've got a model, we can ship it. So that definitely is some promise in that space.
I also think we need to do work on the research side, because there's a problem in academia, and we discussed that in the past, that there's a fear competition. I read once that in academia, people remembers you for two things: be the first one to publish something, or be wrong, totally wrong about something. Everybody else it's ignored. So to be the first one publishing, there's a fair competition to get the samples, right? So if you talk to a doctor who's doing some sort of research, you're going to have a hard time sharing their patient data, sharing the samples that he's been collecting for 10 years in the hospital and things like that. So there's a lot of work to do that there. Like, okay, yes, I have samples. So tumor samples I've been collecting for 20 years, 30 years, but I'm not going to share it because I want to be the first one curing cancer, right? Mm-hmm. So academia has that problem too, that we need to work on it.
But the business has changed too. So now, I think we always paid people by the amount of services you rendered. So if you follow the money, now we're starting to pay people by the quality of the outcome. And that's not just talk anymore. I think a lot of hospitals are really doing that, and they believe it. So I've worked with a bunch of people out of Caltech that are using a Bayesian model to analyze mammography data. So it's probably a well-known fact that about 80% of the biopsies that are performed for breast cancer never needed to be performed. It's a horrible thing. Leaves people disfigured, but these people are applying science to the diagnosis. And that, it sounds like it should be being done now, and it isn't very common. So the more we start doing that, and the more we pay people for good outcomes, I think that we have a better chance of curing cancer, because it's not the goal right now.
Okay. Yeah, I'll take that on too. I mean, I guess one thing I kind of left healthcare as the ASO model, and the new model of paying for quality was kind of emerging. But that's something promising, I guess. We should not overlook that, is that you think, okay, I was working for a payer. The healthcare plan is thought to have all the data because you have all the different providers. And the providers have just their data, but they have much deeper data. And the new world is, with these agreements, you partner together so that you can share the high quality data and the breadth of data too. So I'm not up to speed whether that's being followed through, but hopefully it is. And that's definitely where it's intended.
Thank you. I want to actually ask Francesco one question about sharing genomic data, because that came up in my discussion with this startups working on cancer, right? So because my kind of naive assumption was, there is a patient with cancer, they want to share their data. They will use anything to prolong expectancy of their life. But actually the government would step in and say, it's not just your data. You share genomic information with your successors, right? Even if you die, your children inherit your genomic data. So how much sharing can actually occur? Because we all share a lot of genome, right? All humans descend from common ancestors. So is there actually kind of a scientific limit on what can be shared and can be deduced about your relatives and your children? Can we share all genomic data, or should we kind of limit it in some way?
I'm definitely not the right person to ask that question, though. We have a department only dedicated to that, to discuss data use limitations, to figure out these kind of things. I don't have an answer for that. I don't know. But we encounter really weird issues where, so when we have a finding, a mutation, we don't need to communicate it. We are not, it's not mandatory, right? Except for a few cases. And you have cases where you have brothers that both have the same mutation. One of them doesn't want to know it, the other one wants it. What do you do? Because if you let one of them know it, the other one is going to know that he has the same problem.
Yes.
But he doesn't want to know it.
Yes.
So yeah, definitely they're real weird. That's real. What I'm talking now, it's totally real. It happened. So so you have really weird cases that I don't know how to do with them. Definitely, it's not my field. So
it's not just a data problem. Like, we will have to involve ethics, right?
Yep.
And, very seriously. So I think we have about 6 minutes left. So I'd like to kind of ask folks in the audience. Maybe somebody can help me bring about this famous yellow cube. So if you guys have a question, maybe you can raise a hand, and we can deliver the cubes to you. I think I see a hand there. Is it? Okay, I see a couple hands down this way. Hey. Please introduce yourself and ask a question.
Hey, my name's Jake. I work in the financial space, but my background is in biophysics, so I'm sort of passionate, I guess, about this area. really liked the panel today. I thought you really touched on a lot of the really important points, one of which is that you're dealing with perhaps incorrect data all the time. People are lying or not being completely honest about what is actually happening. You need unbiased data sources as well, like you talked about. Something even as simple as a Fitbit to correlate other types of information. So I guess I just wanted to chime in on that.
Well, genetic data can be wrong too sometimes. I can tell you that too.
Well, yeah, and if you're focusing mostly on exomic sequences, you're missing a lot of the other stuff that you don't necessarily know if it's important because the combinatorics are just so huge. So having a pool of data to even make sense of it all is what you really need. And whether that means delivering a model that you disseminate to a group or a collection of people to make sense of, or just telling what types of techniques you're using to featureize the data itself. That's the most important part of any data science process, is what you're choosing as feature. I don't need to know if somebody lives in Texas in this location to know that a portion of this brain scan is an important feature. So aside from even the models, just the techniques, even just knowing what types of information you are putting into the model, that's more important in and of itself.
Fitbit too, and those things, the quality of the sensors in there is not the best. And we've done studies with them, and people strap them to their dogs, and things like, yeah. So.
Not even saying that that's the answer, just more that you can't always assume that you're going to be able to predict a label, which also needs to perhaps change because, as you know, doctors aren't always sure if it's one versus the other. Yet when we do data science, that is the pure, unbiased thing that we're trying to predict. We have to assume that those are correct. So even calling them something different than, you have cancer, or rather than you have a likelihood of developing this versus this, that's also important.
Yeah, to expand on that, I mean, like, we had multiple definitions within our own company. The government says what diabetes is, and it's this, but you would find your nurses kind of have their own favorite way, because you can't just take a reading of one. Like, we have people who are both type 1 diabetes and type 2 diabetes. Like, no, but that's what the data says, and like you say, it's ground truth, but we know that you can't. But it's, when you think about all the data you're throwing away to require, all these very hard definitions of things, that gets difficult too. To get around the data quality, we're adopting multiple definitions that don't agree of some very basic building blocks too.
I think really fundamentally, though, just one last point, and then I'll pass on to anyone else who wants to chime in, is that you really need to have some sort of incentive, either from the business perspective or from just public perspective, of wanting to actually arrive at a goal. So that might mean from the business side that you need to have less stringent requirements on targeting a specific initiative versus just doing general research, whether that's funding that you're receiving from the government to just apply general research in the area of solving these types of problems versus trying to market it or make a business out of solving something. I think that's all important, is just having more incentives for people to do that.
Thank you, Jake. And I think we actually are out of time. So thank you very much, our panelists. Thank you very much, folks, for listening and your questions. And we'll be around during lunch, so feel free to chat with any of us. Thank you very much.